All right, my friends, let's get started. So for part A, I was hoping that you could see fairly quickly that while we are adding infinitely many terms here, that you actually can get a finite answer. So for part A, I'm hoping that your answer was basically 0.5 repeating. And so if you got that, then congratulations. That is one version of the correct answer. And then another version of the correct answer is 5/9. And if you don't believe me, then just grab your calculator and do 5 divided by 9 on your calculator, and you'll see that you do get 0.5 repeating. So there you go. Now for part B, if you just stare at it, it might not make sense. But one rule of thumb, my friends, with sums is if in doubt, expand it out. So, and actually though, before we get going on if in doubt, expand it out, another important thing is to be able to read something like this out loud. Okay. And so I do want you to practice this with me because it's important that you sound educated, not just that you know what to do, but that you can read things like this. So, so repeat after me. The sum as n goes from 1 to infinity of 3 over 10 to the nth power. Okay, let's do this again, okay? When you see sigma, you would say the sum. So the sum as n goes from 1 to infinity of 3 over 10 to the nth power. Okay, make sure you can read that sigma notation there, okay? All right, my friends, now let's do if in doubt, expand it out. So go ahead and start putting that lower bound in first. Oops, sorry about the weird mark there. There we go. Okay. Let's put in the 1 for n, and you'd get 3/10. Put 2 in for n, you'd get 3/100. Put 3 in for n, and you get 3/1000, and you're supposed to keep at it forever. And if this doesn't make sense yet, then write each fraction in decimal form, and you'll see that it's a lot like part A. And so your answer is 0.3 repeating, also known as 3/9, also known as 1/3. There we go. So 2 examples where you have an infinite number of terms, but you're getting a finite answer when you're all done. All right, my friends, for part C, let's do if in doubt, expand it out again. Okay, you're going to notice that's probably one of your most powerful moves, is the most obvious one. So let's go ahead and plug 1 in for all the n's in the rule. You'd end up with the quantity 1 minus 1/2. Okay, let's plug 2 in. You'd get 1/2 minus 1/3. Let's plug 3 in. You'd have 1/3 minus 1/4. Let's go ahead and go through a couple more rounds of this. In general, you just expand it out until you can figure out what's going on. So let's see, 1/5. Is that right? What am I plugging in now? Oops, I'm on 4, huh? 1/4 minus 1/5. And then it would continue like that forever. Okay, and so part C, my friends, is called a telescoping series. And so, imagine an old-fashioned telescope. So it would kind of expand out. So this is the expanded version, but an old-fashioned telescope would collapse down upon itself, where you could really only see like that outside piece of it. And so, so in this case, notice that you've got some terms that vanish. So like the 1/2 vanish. That means just add to 0. The 1/3 do. The 1/4 do. I hope it makes sense that really everything vanishes in this case except for the very first term, and then whatever that very last term would be way down at the end. And so, and what would the value of that very last term be? Well, it would be 1 over basically infinity. So it'd basically be 0. So your answer would be basically 1 minus 0, or 1. Okay, so at this time, you've got 3 series, and I hope it makes sense. The word series is in the last section, we talk about sequences. A sequence is a list of terms. A series is where you're adding together the value of all the terms that you would have had generated in a certain sequence. So there you go. So series and sums are kind of the same. Okay. All right, my friends. Let's see. So there's some main points, and I know that this was mentioned in the learning targets up above, but let's write them down. So there's some main points of this lesson. We're going to get a ton of mileage out of them as we go through chapter 8. One is the idea of an infinite geometric series. Okay, and another is a telescoping series. And another main point is what's called the nth term test for divergence. Okay, so please do write these down. And then as we go through, we'll make sure that we can check all these off our list. We will get quite a bit of mileage out of these things. I would say if somebody said, what's the most important thing from chapter 8, it would probably be this list right here. Now, I will say, so far you've already had some experience with geometrics. Part A and Part B were both geometric. We'll talk a little bit more about what makes something geometric. And then Part C was a telescoping series. And you pretty much know what you need to know at this point about telescoping series. You expand it out, and then you look for what vanishes and you look for what's left, and then you get your answer. There's more to be known, I suppose, about geometrics. So let's say we could kind of check telescoping series off our list at this point. I guess there's a little bit more we can add to it, but not a ton. Okay, let's see. Let's have you go ahead and play with example 1 here. So example 1 says, evaluate the first 5 terms of the sequence, but not just the sequence of partial sums. And so let me give you an idea as to how to get started on this one, and then I'll butt out and let you finish it. So for a problem like this, if in doubt, expand it out is always going to be an important part of your solution. So for part A, you could start generating the terms. So if n is a 1, you'd have 32 times 1/2 to the first power, which would be 16. If n is a 2, you'd have 32 times 1/2 squared, and so you'd get 8. And you could see as n increases, you're just multiplying by another 1/2, so just cut your previous number down by 1/2. So this is what you'd have. Now, the directions say sequence of partial sums. So let me explain what that means. So a first partial sum would be just your first term. And so in this case, that would just be 16. Your second partial sum is your first term plus your second term. And so in this case, that would be 16 plus 8, which would be, 24. I'll show you one more, and then I'm going to butt out. So your third partial sum would be your first term plus your second plus your third, which would be 28, and so on. Okay, so hopefully that helps you see what a sequence of partial sums is. And then go ahead and finish it out, and I'll check with you in the next video.